is the second half of this review. Again, you get to use this review on the final, and this is the last day that we have to do this if you're doing this in class. So hopefully it makes sense to you. We may have done some of this with your class, and if so, great. Okay, which expression represents the value of k? Well, I know that all three of those would have to equal to 180. So to find 180, I would add those two up, right? So if I did 77 plus 33 and subtracted that from 180, I would get it. So I'd have to do 180, and then 77 plus 33 would be 110. So it would be that one. I don't even have to find the actual angle, just the step. All right, how would you describe the measure of angle E? How could you find the measure of angle E? Well, if we knew what D was and we knew what EF was, we could add them together, right? I could do the measure of angle D plus the measure of angle F. And I could add them up, right? And then do 180 minus them, and that would be the measure of angle E. But in words, we're going to subtract the sum. So here's the sum of D and F. That's what this part is. And if we're subtracting it from, like that thing from means it goes second. So it would have to be A. So from 180, that's it. Okay, number 17. The diagram shows this. It shows the hillside, the slope of the hillside, or the equation was y equals 2/3 x. And then the wire is y equals 2/3 x plus 25. And if a new wire were installed at a constant distance above the existing wire, which best describes the relationship between the two wires in the hillside? Well, if everything was so that's for this one right here. If everything was the same distance, then that would also be parallel. And here's a reminder, parallel means same slope. And since the slope on the hill was 2/3, the slope on this one was 2/3, then it would also have a slope of 2/3. So the wire is parallel to both. It would be both the existing wire and the hillside. They're the same, so it'd have to be both. Okay, which conclusion does the graph support? Okay, so remember that these little symbols here mean parallel. And parallel means the same slope, which means we could look at the graph and figure out slopes. Oof. Okay, let's see. From C, what looks like a point that crosses nicely? Okay, B is right here. I'm just going to look and see if I can find the rise over the run to get this, because slopes are how we decide if they're parallel. And it looks like this one's there. So it looks like this one, the slope of line B, it went up 3 and right 4. And it looks like C does the same thing. From this point to that point, it also goes up 3 and right 4. So I would say, B and D happen to be that. But then if I look at X, looks to me like we would only, just for comparison, I mean, is that line Y? What line is that? Line A. Okay, line A goes, the slope would be up 1, right 1, up 1, right 1. That's not the same slope. And then D, it looks like the next point along here that actually matches it is maybe clear over there, which is definitely not 3 and 4. So up 3 over 4 was the slope of them, and it was only C. Okay, is the line through those points perpendicular through the line to those points? And explain. Okay, so we want parallel. We want perpendicular. Parallel, I'm just going to come up here. Parallel means same slope And perpendicular means slopes are opposites. Means, that was nice, means opposites. So to check off, are they opposites and are they reciprocals? Okay, so the slope, we're going to find the slope of PQ and then the slope of RS. So the slope of PQ. We're going to have the change, that's the change in the y's divided by the change in the x's. Remembering that this is the x, that's the y, x and y. So the change in the y's. I'm going to subtract going this way. So I'm going to do on the top, I'm going to do 1 subtract -2 divided by -6 subtract -4. You can type this exactly into Desmos like this. So we can do, wow, that's fancy. We can do, start with the dividing button, and then we can do 1 subtract -2 on the top. And on the bottom, what was it? It was 1 subtract -2 and -6 subtract -4. So -6 subtract -4. And then it can give me, then I can push the fraction button. Remember that fraction button? So I get -3/2 equals -3/2. And now we can find the slope of RS. Doing the same thing, I'm going to subtract this way. So I can do 3, I want the y's first. JK. Okay. So -5 subtract -3. That's my y's, right? And now 3 subtract 0. And I can do that here. Whoa. Calm down. Zooming in stuff. Okay. So I can do fraction button and then -5 subtract -3 and then 3 subtract 0. Do a fraction and that's -2/3 equals -2/3. So let's start with the first one. Are they opposites? In other words, that means one positive and one negative. Well, nope, they're both negatives. So that means no, their slopes are not opposite reciprocals. Another way of saying opposite reciprocals is we would say their product must equal 1. -1, I mean. So if you multiply them, you would get -1. So like if I did -3/2 multiplied by -2/3, I would get 1s because those would divide cancel, and then I would get, but I get +1. So that would be why. Okay. Now, big pictures. All right. Which of these transformations appear to be a rigid motion? So remember, rigid motion would be the same sides and angles. So let's see. I'm going to look at the same sides and angles. Well, this was 19. This is 19, 16, and 19, but then these are all 16. So I'm going to say no to this one. Now let's check. That's 19, 19. I'm just comparing all the sides, right? So here's 19, that's 19. 8 goes with 8, 10 goes with 10, 19 also goes with 19, 8 matches with 8, 7 goes with 7, and then we have this angle is the same as that one, and this angle is the same as that one. So this would be yes. And then I can see these are not the same size, so it's going to be no on that. So the answer would be 2 only. Cool. Each triangle in the diagram is a reflection of the other across one of the given lines. How can you describe triangle 2 by using a reflection rule? So the little R, so like if it says, like right here, it's really small. It says R with a little L means you reflect it across line. You reflect triangle 3. So this means reflect, I'm going to put triangle 3. This means reflect triangle 3 over line L. So if I just reflected 3 over, like over line, here's line L, and it just like bloop goes over there, that looks good. So this looks like yes. Let's go through the other ones though. Reflection across line M of triangle 2. So here's line M. See how like they're all like perpendicular? If I connect all the vertices, they're perpendicular to each other, like to the line, the reflection line. That one also looks like a yes. Oh wait, we're trying, how can you describe triangle 2? Oh no, you can't do that. So not that one. It is triangle 1 though. So I'm gonna put yes on this one because you can't reflect itself over itself and get the same thing. That's, I mean, over a line and get the same thing. So it'd have to be 1 and 3. So yes, no, and that. So 1 and 3. 1 and 3 only. Cool. Which graph shows a triangle and its reflection image over the y-axis? Remember that the y-axis is the tall axis. In fact, I go like this to remind myself, y-axis, because it's tall. So which one reflected it? Or imagine that there's a fold on the y-axis. So here's the y-axis. Does it look like it folded right there and it was the same thing on both sides, on this one, and this one, or this one, or that one? Well, I would say A, because it looks like it folded, right? Okay, for the sake of the length of the video, I'm going to make another one. We're going to pause.